Chapter L is a chapter on inverses. This is a subject we've learned in the past, but the purpose of doing this this chapter is to essentially review the technique and make sure we're pretty confident with it, especially if you intend to move on to calculus. So let's do the first problem that's in discussion here, which is y equals 4x plus 5 over x minus 1. Okay, I'm just copying it over to Scratch. And let's review what the steps are in finding an inverse. Well, the first step is to get it into a y equals form. So if we had been given this as a form like f of x equals 4x plus 5 over x minus 1, the first step would be to change it into a format where it would be y equals. Okay, now having done that already and you're given that as the format, the next step is to interchange or swap x and y. Swap the positions of x and y. Very easy to do. Wherever you see a y, you put an x, and wherever you see an x, you put a y. It is as simple as that. It's as if you took an eraser and simply erased out the x's, wrote in y's, and vice versa. The next step, which is often the hardest, is to solve for y. Okay, and you have to solve for y explicitly. You can only have a y equals on the left side of the equation and then some function of x on the right. Okay, and in some cases, as we'll see in this case, it could be a bit tricky, but it usually can be done if you use all the algebraic tricks that you know. So let's go ahead and let's start. Well, when you have a fraction like this, we want to try to clear the fraction. Let's cross multiply. I'm going to put it, the left side of the equation is x over 1, and now I'm going to cross multiply and see what we get here. So we've got x times y minus x equals, and we're just multiplying 4y plus 5 times 1. Now remember, we've got to solve for y, which means that we've got to have all the y terms on one side of the equation so that we are in the position to be able to solve for y. So that means we've got to get, if we're going to try to get them all over to the left, let's subtract 4y from both sides, giving us only 5 on the right, and then that gives us xy minus 4y minus x equals 5. Now, we could factor y out of these two terms, but we can't factor a y out of this. This is x. And remember, we really want the x's on the right side. So let's go ahead and add x to both sides. That gives us in terms xy minus 4y equals 5 plus x. And now we're in a position to be able to factor out the y and basically isolate it, which is what we wanted to do from the very start. So we can factor the expression on the left into y times x minus 4 equals 5 plus x. And now, I hope that that was pretty clear how we do the factoring, but now we can divide both sides by x minus 4 to get what we wanted from the very start, which is a function that is exclusively of the form y equals and then some function of x on the right. This is the answer. We needed to show graphically that the inverse is a function. So that's just a matter of punching it into our calculator. So let's go ahead and do that. Let's turn this on, go into our graph mode. I'm sorry, maybe our y equals mode, and then put 5 plus x. Remember, I want to use my parenthesis here. 5 plus x divided by, and I'll use my parenthesis again, x minus 4. So I've got that set up. Now I just want to graph it, but I may also want to zoom it because I don't think my graph zoom is set up properly. Well, let's see what we get because this has been, zoom is just not right. Let's zoom it to standard and let's see what that does for us. Okay, well that gives us a better view, right? And what we see here should not be very surprising because we should be able to predict the appearance of this curve from the equation itself. Before we get into that, let's just take a look and confirm that this does look like a function. Well, it appears to be crossing the x-axis and becoming slightly positive over here. We appear to have a vertical asymptote around here, it looks like at about 1, 2, 3, 4, about x equals 4, it appears we have a vertical asymptote. And then we've got a curve coming down and then continuing to the right. It looks like it would pass the vertical line test. So it looks like it's a function. Let's actually zoom out a little bit just to get a little bit more perspective on this. If we were to zoom out, let's press enter. Okay, because of the thickness of the lines, it's a little bit hard to tell. But let's take a look at what we would expect. Do we expect to see the asymptote at x equals 5? Yes, we do, because at that point the denominator is 0. We don't have a common factor between the denominator or the 0 in the denominator and the numerator. So it's not a whole that we're seeing. It's an asymptote that we're seeing. And I think if you remember, so we can say the vertical asymptote is of the form x equals 4. And the horizontal asymptote, if you remember how we came across deciding how to determine a horizontal asymptote, is the way we do that is look at the x values in the numerator and denominator, compare the degree of the highest degree term. In this case, both are of degree 1. And if both are of the same degree, look at the ratio of the coefficients of those terms, and that ought to give you y equals a constant. Whatever that constant is, that's the horizontal asymptote. And here, the constant in front of x in the numerator and denominator is both 1. We don't see a coefficient because it is implied to be 1, and 1 over 1 is 1. So our horizontal asymptote here is y equals 1. And that's what we see when we looked at the equation on the graph.